For this lesson, we're going to start getting into some furnace efficiency ratings. So with any type of furnace that you have out there, especially all of your forced air gas furnaces, they all have an efficiency rating. Okay, that rating is what determines the amount of heat that is transferred to your heat medium. Now, usually when we're dealing with stuff like this, we're either going to be heating up water or we're going to be heating up air. Okay, the following factors also determine what the efficiency of a furnace is going to be. Example, the type of draft that we run into. Now, with the types of draft, it could be a couple different ways. It could be natural or atmospheric draft, such like in a standing pilot type furnace. Your induced draft or your forced draft. The amount of excess air used in the combustion chamber also will affect a furnace efficiency. The temperature difference, or delta T, of the air or water entering and leaving the furnace is going to also affect it, and how hot your flue stack temperature is. The following are furnace classifications and approximate AFUE ratings. Okay, again, AFUE stands for your annual fuel utilization efficiency. So your conventional or standard efficiency furnace, those have a AFUE rating, again, of around 78 to approximately 80%. And will have the following. They will have an atmospheric injection or draft hood on them. They usually will have or use approximately 40 to 50% excess air to support combustion. They will have a delta T of anywhere between 70 and 100 degrees and have the lowest CFM airflow of your furnaces, which means the blower is probably running at its lowest speed. Your stack temperature can be anywhere between 350 and 450 degrees. They are non-condensing and will have only one heat exchanger. Your mid-efficiency furnaces are going to have an AFUE rating of anywhere between 78 and 83%. They will usually have an inducer motor or some sort of first draft hood going on in there. They use a 20 to about 30% excess air. They have a delta T of somewhere around 45 to about 75 degrees. They do use more CFM airflow than your conventional units. It will have a stack temperature of somewhere around 275 to about 300 degrees. Again, they are non-condensing and will have only one heat exchanger. Your high-efficiency furnaces, however, will have an AFUE rating of about 87 to 97%. They will always have a forced or induced draft inducer motor on them. They use approximately 10% of your excess air. They will have a delta T of anywhere between 35 and 65 degrees and have the highest CFM of all furnaces. Your stack temperature or flue stack temperature is going to be anywhere between 110 and 120 degrees. And remember, your high efficiency furnaces will be utilizing PVC for their combustion air intake and their flue exhaust. Usually with your high efficiency furnaces, they will have 2 or even possibly 3 heat exchangers in them. They are condensing, and the reason why they are condensing furnaces is because they reclaim the latent heat of condensation by condensing the flue gas water vapor to liquid water. And again, they use PVC pipe to avoid corrosion. Your high efficiency furnaces have a low delta T due to the increased amount of air they receive through their heat exchangers. The air is in contact with the heat exchanger for a shorter period of time. Your AFUE rating is calculated by the manufacturer of the fuel burning equipment. The higher the rating, the more efficient the combustion equipment is at converting fuel to useful heat energy. So for example here, an 85% AFUE value means that for every BTU of fuel burned, 85% of that fuel is actually being used to heat the building. The 15% of it is wasted out the flue pipe. Another efficiency rating is the HSPF, which is your heating seasonal performance factor. And this factor is applied to your heat pumps and the heating mode and takes into consideration the energy used during the entire heating season. The HSPF is the ratio of BTU heat output over the heating season to watt-hours of energy used. So as of 1992, the AFUE of condensing furnaces must be over 90%. There are some of these types of furnaces out there that are running about 98% efficient.